Welcome. You are about to view a recorded talk from the online seminar series Progress and Visions in the Scientific Study of the Mind-Matter Relation, held in 2018. The seminars aim to bring together researchers from around the globe with a background in mathematics or physics who are interested in the scientific study of consciousness and the mind-matter relation. While each seminar session consists of a talk and a discussion, the latter is not recorded and the following video will only contain the talk. We hope you enjoy it. For further information, please visit mind-matter-relation.org.
So the topic here is where I framed it, that does quantum ontology enable the causal efficacy of consciousness? Of course, we could, maybe I formulate the question fairly quickly, but we could still think about what's in the question. It's perhaps asking whether there could be some kind of it's about possibilities. It doesn't yet claim that consciousness is causally efficacious, but it's more addressing the issue whether physics would exclude such efficacy. And you see now this business about causality in philosophy. Let's see if it will change. Yeah. You see, philosophers, of course, have worried about causation, the notion of causation, for a long time. And it so happens that today, if you look at the philosophical literature, there are these two seemingly conflicting lines of thought that are influential. And you see, some people think, and this goes back to Russell. No, sorry about that. This is the first point. The first point is something quite common in philosophy of mind. Philosopher of mind, just as Jaegwon Kim would say, that causation can only take place at the physical level. And then there's another line of thought which goes back to at least Bertrand Russell's maybe 1912, which claims that causal notions cannot play a role in physics. And you see, both of these views have kind of supporters in contemporary philosophy. So, people are actually paid salaries to think. One thinks in line one, and the other people think in line two. So this is philosophy for you. So it's not only in physics where you have all these different interpretations. There was actually I got this inspiration for this thing. There was a workshop in Umeå University where you got the reference where really some of the leading people in this field were participating. And so this is the and so I say a little bit about these things now. Okay, so first this first idea, people say causation can only take place at the physical level because all goings on in the world are ultimately determined by physics, and physics itself is causally closed. And this is the famous principle of causal closure, which we could define as saying that if a physical event has a cause, it can be described entirely physical terms. This is the idea of the causal closure. It could so happen, if certain interpretation of quantum mechanics is true, then, we could have events that have no cause, kind of radical indeterminism. But if there is a cause, then it should be physically. And you see, what happens is that in philosophy of mind, I'll say a bit more about that later, but still, a lot of philosophers do not want to reduce the mental to the physical domain. So they say that mental properties are in some sense non-physical, but then there's a threat of epiphenomenalism, meaning consciousness has no causal powers. So that's kind of one of the debates, and I'll be actually mostly talking about this first issue here. If you like, my talk really is asking, well, could quantum theory help us to avoid this epiphenomenalism or allow us to look at this thing in a new way? But there's also this other stuff which is kind of interesting, which I'll just mention as a bit of a new, partly for everybody and partly for the people who've heard me talk about this before. So you see, then there's this other view. Causal notions cannot play a role in physics because the fundamental laws of physics are radically different from causal laws. And what are people saying here? Well, they're saying that causal laws typically describe how local events determine events in their future. For example, a causal law can connect smoking to later occurrences of cancer. By contrast, physical laws connect the entirety of physical reality in a time-symmetric manner. The entire state of the universe at a certain time equally determines the relative past and the future of the universe. Now, when people, when they look at this, people say, well, perhaps it's reasonable to situate causation in the higher levels of science, where local events are studied in a time-directed manner, such as biology and economy. And this, again, pretty much this text here comes from this conference description. It was so well written that I'm just using it over here, just to summarize this situation. You know, and there's much more to this. This will be another talk to really go into this, and I'm actually going to be talking about this in a consciousness conference in Tucson in a few weeks. This will be, you know, early April. But still, well, I kind of move on to the epiphenomenalist debate, but perhaps come back to this at the end a little bit. Just maybe keep this one in mind as well, and you may have questions. Okay. And of course, you see, you know what? So I'm interested in these two views of causation. Well, since the mid-1980s, I've been working on a program which involves, on the one hand, a causal interpretation of quantum theory. It's called the ontological view, but it's also called a causal interpretation. And also an extension of this quantum ontology to include mental states and their causal efficacy. So this kind of pretty much has been my thing, if you like. So I get worried when I hear that there's no place for causation in physics. And this is what the other, you know, one group is saying, but also there's no place for the causal efficacy of mental states, which is like what the physicalism is to imply. So I find myself very puzzled, and this is what I've been actually, this question is what I kind of been thinking about over the past few weeks or months. Okay. But still, let's, sorry, oh, I have to press this one here. But of course, here the problem, if we move on to this problem of mental causation, or, you know, the question of, well, is there room for mental causation in the physical world? And you know, something of the problem can be already found in Plato, where here Plato is saying that Plato acknowledges that without bones and muscles and the other part of the body, I cannot execute my purposes. But then Plato continues to say that I do as I do because of them. And this is the way in which the mind acts, and not from the choice of the best. It's a very careless and idle mode of speaking. I wonder that they cannot distinguish the cause from the condition, which the many, filling about in the dark, are always mistaking and misnaming. So if you like, if we relate this to this business about the causal closure of the physical domain, we can see that Plato is kind of not happy to agree that our actions would be completely from the physical domain or from, you know, the bones and the muscles. It's at least implicit, the kind of dualist views that they're, you know, the choice of the best, a kind of a more mental act, something perhaps not physical, that's also playing a role, and which is actually why we do things, which is kind of cause. So this is just to give a bit of an illustration that the problem is old, but it's still been pretty the problem has been pretty alive in the recent decades. And when I was, doing my PhD in the early 90s, people were talking about mental properties, mind, not necessarily so much about consciousness. But over the past 30 years, 20, 30 years, there's been much more focus on conscious experience. And so, but the same problem arises. It's people now say, well, we should take consciousness seriously, and conscious experience is, a target of study. Simple example of conscious experience is in the dream-wake cycle. When we fall asleep and enter a part of sleep that's pretty much without dreams, we lose something, and the interesting question is, what exactly is it that happens? What is it that we lose? Is there what's the nature of that thing that we lose? And again, when we wake up, what is the nature and the character of the thing that we kind of gain? And it's a huge discussion that a lot of, I'm happy to give references also if people want. But anyway, but the question is whether consciousness has causal roles. You could also put it in a bit more careful. You could ask, does it make any causal difference whether or not an organism is conscious? You see, could it be just that the information processing could take place in exactly the same way with or without consciousness, so that we, are zombies possible, as they say? Or could it be that we actually are zombies, like Dan Dennett thinks? And you see now, so there is a problem. I mean, I won't go into too much into this, but there's basically a problem to understand what, if any, causal role consciousness plays as consciousness, not the neural correlates of consciousness. That's not the thing people are worrying about. Most people agree that there are neural correlates of consciousness, but a lot of people also think that, well, you can't reduce entire conscious experience into those correlates, and therefore the question remains, does consciousness do any causal work? And of course, the philosopher Kim has said that an existence without causal powers is an existence not worth having. Of course, not everybody would agree. Maybe numbers have an existence and so on and so forth, but still. And here I mention again that what I already told you about this causal closure of the physical domain. And you see, well, the problem is easy to solve if we can show that consciousness is physical. But if there is causation, however, that's the so-called hard problem of consciousness, as David Chalmers would put it. So that this is kind of the way we could frame the issue. Now, the thing is that I think if you do philosophy, read the literature and philosophy of mind, and it so happens that you have studied a little bit of physics, even as a hobby, you get frustrated that the discussions pretty much ignore the new physics, and so Lademan and Ross go as far as to call contemporary analytical metaphysics neo-scholastic, which is kind of a derogatory term here, or at best A-level chemistry. So this is they wrote this fairly polemic book called Everything Must Go, and so that's where they really say that philosophers should really take into account natural science. And so the terms that are using that, what we need is not just an armchair. I mean, I personally believe that so-called armchair metaphysics can be very useful, but we also need to add the scientific bit to it. And one way to understand what is a scientific metaphysics is that it's a general framework that's implied by our best theories in physics and the special sciences. We don't need to claim that physics has somehow, it's an open question what's the importance between the physics and special sciences. But somehow the idea that still maybe we should take science into account here. And so let me see if this jumped. What happened here? Yeah. Now, and here, so that's what I propose here, is that a good candidate for such a framework is Bohm and Hiley's implicate order program, which includes an ontological interpretation of quantum theory. And so this is, of course, a big question that, and I think a lot of people find a bit confusing, the connection between these two, because if you study these things, you'll realize that the implicate order is a very general program. Bohm says that we should axiomatically start from a notion of order and work from there towards a more radical order that goes beyond the Cartesian order. This is the implicate order is something from, for example, where space-time might unfold. So it's a bit kind of perhaps similar to the currently fashionable emergent space-time programs. However, as Bohm is better known for the so-called de Broglie-Bohm theory, or hidden variables, or the pilot wave theory, which he himself called the ontological interpretation, because he felt that the key point was that it was trying to give a concrete picture of the nature of quantum reality. So he claimed that it doesn't matter so much if it's a deterministic version or indeterministic version. It's the ontology, the notion of reality is the important one here. And so this is what I've been sort of focusing on. And so and what's interesting here for this question of mental causation is that this interpretation, it proposes that there's a new type of holistic active information that plays a key role at the quantum level. And we'll say a bit more about that, but the point here is that when we hear the word information, we perhaps think, well, this is something for us. But the idea here is that we think of here information more as an objective commodity that is influencing things, but we'll come to that. Okay. And of course, if we think of the philosophical discussion, we could say that this involves a radical change in what we mean by physical, and this opening up a new ways of tackling the traditional mental physical problem. So here, actually, I did my thesis in '92, sketching this, and then I've got a couple of papers about that. The idea is that information can now be seen as a new fundamental category. And of course, this idea has, it's a lot of people have been proposing a similar idea, but this is still, if you like, one version of it. And the naive idea here is that according to Bohm, he made a proposal that this quantum information, in his sense, we could call it the Bohmian quantum information, connects the physical and mental domains, as these latter have been traditionally conceived. So there was a paper, it was a sketch, but still I think that before he died, he managed to outline some of these ideas. Okay. And of course, I guess many of you people know that, this so-called Bohm theory or pilot wave theory, it used to be sadly ignored like Finland in a Monty Python song, but it's been a bit of a comeback. And here's Mike Towler's. For those of you who are interested, there's a very good kind of graduate level course on the Bohm theory on the web, which Mike gave in Cambridge, Mike Towler. And this little anecdote with this poster, when Mike sent this title to Cambridge Physics Society, they felt, oh my, yeah, this is a bit too much. Why don't you just say that why Bohm was right? But poor Mike, he insisted, and I don't know if he has a job anymore. So probably he has something, but maybe not the dream job he was dreaming about. Anyway. It goes a bit too quickly here. Let me see. Why do I jump to? Is it just a, yeah? So anyway, I think here I assume that there are many physicists in the audience, so I apologize for the simplicity of the presentation at this point. But this is just, you know, the way the de Broglie-Bohm theory works, and of course, you know, there's a lot of confusion about these things in the popular press. But here it's assumed that an electron is a particle which has a well-defined position and momentum, and it's also accompanied by, guided by a field which satisfies the Schrödinger equation. And so so this is just maybe for the uninitiated. It's not particle or field, like sometimes Copenhagen views. It's not a field which collapses into a particle, which is perhaps the von Neumann view. It's not a field which branches into many worlds in the kind of literal sense, like in the Everett. It is particle and field, or as Bohm used to say, an inseparable union of a particle and a field. So Bohm didn't think of these as strictly separate categories. And of course here, I think most people are familiar with this, but this is the way, a very schematic way to show how this theory does the two-slit experiment. And so, and perhaps even here one should mention that, like, you know, these particles could be sent one by one. Each particle goes through one slit or the other. The wave goes through both. The wave interferes and then somehow guides the particle so that if we pass, let's say, 100,000 particles, we will get an interference pattern. And it could be the case that the field just pushes and pulls the particle, but kind of the interesting thing here is, at least for Bohm, it was that we shouldn't think of the field pushing and pulling the particle mechanically, but we'll come to that a bit later. And this is from Basil Hiley. I unfortunately don't know how to make nice slides like that. I'm actually gradually, I should learn to how use this, but this is for those of you who are familiar with the mathematics, and you can see the just the way this works is that the Bohm theory is that it's a standard way. You can write the wave function in so-called polar form, and then put that into the Schrödinger equation, and you work it out, and then you'll get, as a real part of the equation, something that looks very much like the Hamilton-Jacobi equation in classical physics, but there's an extra term q, and then again, as many of you know, that even long ago, when people were thinking about how to get from quantum theory to classical physics, there was the so-called WKB approximation, which you did by just choosing this form of the wave function. And then what people then did was to sometimes counterfactually just ignore the Q. And that way you would get your classical Hamilton-Jacobi trajectories. And if you like, one of the simple ways, you know, de Broglie actually discovered pretty much this sort of thing in the 20s, but Bohm didn't know about it. And the way Bohm tells how he discovered this was just that he was puzzled that, you know, you start from quantum theory, which doesn't really have an ontology. Then you eliminate something, you eliminate Q, and you suddenly get an ontology, like as if you got a rabbit out of a hat. And then he asked himself, so what happens if I don't approximate? Because it's actually a counterfactual thing to approximate it, at least in certain situations. I mean, there's no physical reason in certain situations why you should get rid of the Q. And then he realized that it has the dimensions of energy. So he realized that you could actually actually do quantum trajectories. And I remember even though it's kind of, people think it's fairly simple once you know how to do it, but Bohm sometimes wrote in a letter to maybe an ex-girlfriend that he really felt that how come he was the one to see this, that he really felt at the time that it was a great discovery for him, that given that everything you see here is what all those people in the slide said was impossible. That's why Mike Towler wanted to say that all these people were wrong, because all of them had said that you couldn't do this sort of thing. But still, the other side is here that we of course we do not know whether this is what's really going on. This is a hypothesis, right? But the way it happens here is that when you look at the quantum potential, then we are looking towards the screen, so the electrons will be coming toward us. And then, the potential is a bit like a mountain, so the electron doesn't want to go up to the high places. And then you look at, on the left side, you look at the trajectories, you can see that there are no trajectories where the potential is very high. So these two pictures go quite nicely together. So it's of course, I think for philosophers of science, there would be much here to discuss about, in terms of explanations and models and things like that. But I guess philosophers of science have been kind of fairly lazy talking about these things. I mean, some of them, of course, have done it, but anyway. But we'll move on. I mean, we can. So we could ask. Well, you see, we said that the quantum field influences the particle, and this is where the thing gets kind of interesting, at least for philosophers, and maybe it gets a bit crazy as well. But we'll see. So what they were proposing is that the field carries information. For example, about the structure of the environment, just as the presence of slits. And this is, of course, I mean, if you're a physicist would understand it, because, when you solve the Schrödinger equation, you put the kind of significant things in the environment as boundary conditions to the equation. So when you solve the Schrödinger equation, the quantum field will reflect whatever was, it will reflect the boundary conditions. But in that sense, if we think of the psi as a real field, like something that objectively exists, then we have an entity that is also related to the environment in which is. So in that sense, there's a kind of an aboutness there, or correlation. I mean, one could look at this in more detail with the notion of information. That I've done a little bit of looking at in terms of Floridi's notions, but perhaps not going so much here. But the idea is that there is this kind of the way quantum field encodes information and then manages somehow to inform the movement of the particle. And in this sense, we could ask, well, is information a causal factor here? There we go, yeah. So the question is that what matters here is that, so the quantum potential would depend on the second spatial derivative of R, which reflects the way in which R changes or the form or shape of the wave. And it depends only on that. Of course, well, M and H bar, they are constants in this, or they're not changing in this picture. And in this way, the idea was that the quantum wave is not pushing and pulling the particle mechanically. So let's have the next one. And this is, of course, they kind of proposed this already back in '83 and acknowledged themselves that this kind of idea of particle responding to information is far more subtle and dynamic than any others that have hitherto been supposed to be fundamental in physics. So that's their own kind of evaluation, and of course that is not a universally shared view, but then again, some people find that interesting. But let's have the next slide.
Yes, coming up.
And then, so here is this note. So the naive idea of the active information is just that if there's a form that has very little energy, it will enter and direct a much greater one. And then what you do is that you get the greater energy will then get the form of the smaller one. And let's have the next.
Yes.
And there are a number of examples they discuss in the papers. Of course, there's the ship on autopilot is quite a nice one, where the radar waves are not pushing and pulling the ship, but rather informing the process. And there also the DNA molecule is, guiding protein construction through the RNA. There again, it's the form that's significant. But also when we move on to the human subjective experience, when we are reading a map, we don't have to eat the map. We abstract the form in a good old Aristotelian fashion, and then we get information content, and we're guided by the information rather than we are not being pushed and pulled by the light waves. That it's kind of an internal process. But let's move. And then again, the sum of it's important to distinguish this from the Shannon information, where what's important is the way a state of system is uncertain to us, whereas here we think of active information as not essentially related to our knowledge or lack of it. This is information that's relevant to determining the movement of the electron itself. It's information for the electron. Also, information is an objective commodity, something that Dretske was using, although in a different way, but still. Let's take the next one. And now, let me see. We can go back to philosophy of mind, and where we remember that many professional philosophers worry that there is no room for the mental in the physical world. And here we have Bohm highly suggesting that information is a fundamental aspect of the world. And now we could, of course, ask, well, is information physical or mental? Let's take the next one. And of course, here again we can see a bit already what I said, that of course one big question is how we characterize the mind. So Bohm liked to say that an essential quality of mind is the activity of form rather than of substance. Presumably activity of substance here means the kind of push and pull processes. And and the idea is that when we are informed, then there's also something we could call information content that's arising, which then will be manifested actively. Let's move on. And this is another view, is that a major part of the significance of thought is just the activity to which a given structure of information give rise. And this is almost, it's a bit, I think William James had a similar idea. It may well be that Bohm got these ideas from, he didn't acknowledge very often, but and then again, even behaviorist theories of meaning sometimes are a bit like this. But anyway, so here we just move on.
Sorry, yeah, okay.
Yeah, that's fine.
Okay.
And there's this kind of a paradigmatic example of this, and where you're walking in the dark night and you see a shadow, and if you interpret that as danger, then that will start a psychosomatic activity. And that's a kind of an interesting example in the sense where it's the meaning and the interpretation that plays a key role, and also in us as the physical. So when philosophers of mind worry about this mental causation business, here the question is really whether meaning is something purely physical, or whether meaning involves or whether some sort of different kind of process is taking place. But anyway, let's move on. Shakespeare had it also, so, but we move on. And the of course the idea here is of course that if we of course, to say that the active information is playing a role in quantum level may sound very weird, and Bohm would kind of say that actually this is a very common feature, which just extend even all the way to the quantum level. And in our psychological reality, it's extremely common that, you know, if we get information that somebody's our friend or an enemy, it will have, or good or bad, it will influence greatly what will happen. So anyway, let's move. And so the here it comes something that sounds a bit like aspect monism, in the sense that this active information is presumably simultaneously physical and mental in nature, and could be a kind of bridge between these two sides of reality. And so when we are thinking about something, this information out, we feel to be on the mental side, then that the idea here is that this information is at the same time a related neurophysiological, chemical, and physical activity. So that there's a sort of a information has these two aspects really, which again, I mean, we could then ask, well, how do we understand this? Is in some ways the mental aspect influencing the physical aspect, and you know, these things we need to look into more carefully, but we'll move on for now. And one idea that comes here is this idea of mind as a hierarchy of levels, where just as we look at physical objects, we can, if you like, mentally look at our thoughts, and this is an idea that we find in so-called high-order theories of consciousness as well. But in this case, Bohm had this interesting idea that this higher level will also organize the lower. So it's a more dynamic view. Perhaps in some of these high-order theories, there's kind of a more passive relationship between the lower order and higher order levels. But let's have a next one, please. And the a connected idea was that Bohm felt we could also see matter as involving a hierarchy of level. So remember, there's this quantum potential that guides the particle, but there could also be a superquantum potential that can then guide the first order quantum potential, which Bohm claimed this would be very easy, you know, mathematically a natural extension. And of course, if you do that, then your wave function would no longer satisfy the laws of current quantum theory. So, you know, there are other ideas like this, a bit past Penrose and some similar ideas, but anyway, so we speculate there might be a hierarchy of these potentials. I'll have a next one. And that's how we get what I call the Bohmian mental causation, where that which we experience as mind will, in a natural way, ultimately move the body by reaching the level of the quantum potential and of the dance of the particles. And so note that this doesn't mean that we are reducing mind to quantum level, but it's only one stage in the process. And of course, this is kind of you see, this is kind of a proposal that quantum theory might actually play some role in the in these mind matter processes. And you know, Basil Hiley and myself, we have looked a little bit this idea in relation to Beck and Eccles' model of exocytosis, synaptic exocytosis, and but still, of course, this is currently a speculative area. But anyway, here's one scheme how this might work. Let's have the next one. And now I have a few more topics to go. I guess I lost a little bit of time there, but
Sorry.
But it's up to us whether how much more I want to do that. What do you say?
I think you should definitely go on for another 10 minutes at least. I mean, we did start a bit late after our introduction and did lose time.
Right. Okay. So we'll move on to the consciousness, and remember, if we think about conscious experience, not just mind, which could be unconscious, but consciousness, and Bohm saw nature as a dynamic process where information and meaning play a key dynamic role. But he also assumed that 99.99% of our meanings are not conscious. So, this was in an interview, so maybe he didn't think of the figure that seriously, but still, we could ask, well, why is there sometimes conscious experience associated with the activity of information? That seems obvious, at least with humans and higher animals. Why doesn't all the activity of information in humans proceed in the dark, as it seems to do in physical and biological processes in general? And here we, of course, ask the question out of our kind of common sense view. And so, so one thing, as we saw, there was the hierarchical structure in the scheme, so we could use a higher order theory of consciousness and say that what makes a given mental state or level of information conscious is that there exists a higher level of typically unconscious information, which has the content that one is in the first order mental state. And note, the higher order doesn't need to be conscious, otherwise you will get into an infinite regress here. So it's more like almost that you have two levels of thought where this two unconscious things, you put them into certain relations, and if this has the content that it is in that state, then it makes the lower state conscious. But the higher state need not be conscious. I kind of think it's an interesting possibility. But anyway, let's go to the next one. Those of you who know consciousness studies, you know that there's a lot of discussion about Tononi and Edelman and even Chris Koch, this integrated information theory, where the idea is that kind of, let's say, a transition from non-conscious to conscious happens when information gets sufficiently integrated. Another theory of consciousness, which is has been much discussed, is Barr's global workspace theory of consciousness, where the idea is that consciousness has to do with situations where information is globally available. And again, we could connect that idea to the Bohmian scheme, or perhaps combine and modify these theories. These are just sort of kind of ideas. And now the other thing is to connect this. Think about the relation to David Chalmers' views. Chalmers said that we should tackle the hard problem of consciousness with the double aspect theory of information, where information is a fundamental feature of the world, which always has both a phenomenal and physical aspect. You can move on when I stop.
Sorry, I tried to anticipate.
Yeah. And you see, we could take the Chalmers side. Bohm himself was kind of not very clear about it. I mean, I think he sometimes says it's obvious, let's say, that the electron has no, it's not conscious, and so he wasn't panpsychist in that the usual sense. But at the same time, if we do think of ways of approaching the hard problem, we could take the David Chalmers idea of the Bohm scheme and postulate that active information too has always physical and phenomenal properties. And okay, what should we say about the active information in the pilot wave of the electron? And as I already said, Bohm didn't really go all the way with it. So that's next slide, please. Now, what we could do is to restrict Chalmers' hypothesis and postulate that certain kind of active information has the potentiality for phenomenal properties. For example, holistic active information that is analogous to quantum active information. But we could add that this potentiality is actualized only in suitable circumstances. For example, when a given level of active information is the intentional target of a higher level of active information. Next, please. So, of course, we here get the possibility of a genuine artificial consciousness, at least in principle, because if we could implement this kind of information artificially, then phenomenal properties should actualize by hypothesis. But next one, please. And you see, I would say the major difference with Chalmers is that the Chalmers theory really seems to suffer from epiphenomenalism. Bohm's scheme opens up the possibility of a genuine causal efficacy. And you see, if you read Chalmers, you notice that he thinks that it's an interesting possibility that some sort of activity is required for experience. And the static information, for example, information in thermostat in a constant state, is not likely to have experience associated with it. And so if we say that phenomenal properties are always properties of some kind of Bohmian active information, we could do justice to the intuition that activity is required for experience. Next one, please. So we start concluding here. If we go back to our quote from Phaedo, Plato there says that it's obvious that our physical actions depend upon the choice of the best. And a typical materialist would say that insofar as physical actions are determined, they are determined by the physical state in a previous moment, including bones and muscles. And what I'm suggesting is that the active information view allows for a naturalistic grounding of Plato's view. Next one, please. You see, Bohm and Hiley wrote already, it's maybe 83, that there are good reasons for expecting that quantum theory would be relevant when we are studying consciousness itself, as based on the material structure of the brain and nervous system. Next, please. It may well be that in our mental processes, the quantum information potential is significant. And you see, what they already there raise is that this is suggested by the fact that information regarded as correct is active in determining our behavior, while as soon as it is regarded as incorrect, it ceases to be active. It's also a little bit this, if somebody would come and shout, you're in a room and somebody shouts fire, and you think this is correct, then you do the sort of things you should do. But then if you realize, oh gosh, somebody was joking, or it's not true. So anyway, so they are suggesting that they're taking this example. So let's say next please. So the way we perhaps in philosophy would say is that our veridicality judgments play a key role in determining whether or not information acts. So for example, if I judge a shadow in a dark night to be an assailant, I get this psychosomatic reaction and so on. Next, please. And we could expand the idea toward Plato and assume that our ethical judgments, for example, the choice of the best, can typically also affect the way information is activated and consequently our behavior. The quantum theoretical active information scheme enables such activity of information to reach all the way to the level of fundamental physics. So we can begin to make sense of a perennial puzzle in Western philosophy, namely the place and role of minds, meanings, and morals in the physical world. And let's have a next. So here's just a summary of this picture and of what we've gone through, and maybe we can still have a next slide. I added a little bit about causation to the end, so if we move on. You see, if we think about the current debate of causation, which I mentioned in the beginning, this kind of complicates it a little, but I'll just say one last bit. So, remember, some people say that, philosophers say that causal notions cannot play a role in physics. And I would say that this line of thinking seems to presuppose Newtonian physics and mechanistic philosophy. that if we have kind of what we might call a non-mechanistic philosophy of nature, there could be a room for causality. And I just throw in a couple of more things here, which this is kind of work in progress. But the usual interpretation of quantum theory implies that statistical causality is irreducible because of the uncertainty principle. However, recent developments in the interpretation of quantum theory, so-called Bohmian mechanics, may eliminate causality from fundamental physics, ironically because of determinism. So I'm just throwing these things here to confuse you very quickly. Just you have to think about. You can. So you'll read my paper when I open those up later on. What about the thing about causation can only take place at the physical level? Well, what I've suggested today is that quantum theory implies that physical may essentially involve objective and active information, thus suggesting a place for mental states in the causal order of things. I think I can end there. You can, if you put the next slide, there are a couple of recent papers then. Well, actually, this one is, yeah, this is the, you could put the, just put the
one below.
Next one.
Okay, yeah.
This one there. This is, here are some of the papers if you want to. But anyway, I'm done 1936, so.